through the research sample collection process.
Over the course of the trial, you may need to request additional supplies. This can be done by filling out the Atrium resupply order form. This form will be provided in your initial shipment, but is also available online on the Atrium eStockDat website, in the lab manual, and in the manual of operations. To request supplies, simply indicate the item and number needed, then fax to the Atrium Coordinating Center. As a reminder, it may take up to 7 business days for supplies to arrive, so please monitor your supplies and order early if you are running low.
The first step in the research sample collection process is to gather the necessary supplies. We are now going to show you the supplies needed for blood draws and processing. From the left, a butterfly needle, tourniquet, alcohol pad, Band-Aid, gauze, a 10 milliliter EDTA tube to collect plasma for research sample 1, a 5 milliliter gold top tube to collect serum for research sample 2, a CPT tube to collect PBMCs for research sample number 3, and a 10 milliliter EDTA tube to collect plasma for research sample 4. A pipette controller, a 5 milliliter serological pipette, a 5 milliliter transfer pipette, 15 milliliter conical, labels for cryovials, marker, cryovials, cell freezing container, and ice bucket. Research sample 3 requires the use of PBS and CryoStore cell preservative solution. Of note, some sites may receive CryoStore in vials rather than bottles. The next step in the research sample collection process is labeling the cryovials. Each supply kit includes pre-printed stickers with a research sample ID number and barcode, along with pre-printed cryovial labels that contain research sample ID number, visit number, research sample type, and vial number. Before collecting blood on each research visit day, first remove a research sample ID sticker from the sheet and apply it to the blood sample collection form in the designated location. Then remove an appropriate cryovial label and apply it horizontally to the cryovial. Depending on the visit day, there will be anywhere from 6 to 12 total cryovials. Following labeling the cryovials, the next step is to draw blood from the study subject. Using standard aseptic technique and the provided venipuncture supplies, collect blood into the appropriate tubes. Recall that different tubes are needed for different visit days. Attempt to fill each tube completely. The next step after the blood draw is blood processing. Blood processing for research samples 1 and 4 is the same, so for the sake of simplicity, we will show the processing for research sample 1 only. The first step in processing is centrifugation. Tubes should be centrifuged at 300 G for 15 minutes with the brake off. Ensure that the centrifuge is balanced. Following centrifugation, carefully and slowly remove the tube from the centrifuge to avoid disrupting the pellet. The next step is to collect the plasma layer. This can be done, if available, with a pipette controller and a 5 ml pipette. If those are not available, a 5 ml disposable transfer pipette is acceptable as well. To remove the plasma layer, first remove the top of the EDTA tube, then using the 5 ml pipette, aspirate the yellow gold liquid above the red blood cell pellet. And dispense it into the 15 ml conical. Always ensure leaving a small amount of residual plasma to avoid aspirating any of the red blood cells. Following isolation of plasma, the next step is to invert the 15 ml conical tube 5 times to ensure adequate mixing. Plasma then undergoes a second centrifugation step, this time at 2000 G for 15 minutes with the centrifuge brake on. Always ensure that you use an adequate balance in the centrifuge. Following centrifugation, remove the 15 ml conical from the centrifuge carefully to avoid disrupting the pellet. The final step in plasma processing is dispensing the collected plasma into the pre-printed cryovials. To collect and dispense the plasma, a pipette controller and a 5 ml serological pipette can be used if available. If those are not available, a disposable 5 ml transfer pipette can be used instead. Use the pipette to collect the plasma from the conical tube, being careful to leave a small residual volume of plasma at the bottom to avoid disrupting the pellet. Count the volume you have in your pipette and dispense equal volumes across the 3 cryo vials. For research sample 2, the first step in processing is to allow a clot to form by leaving it undisturbed at room temperature for 30 minutes.
Following at least 30 minutes for clot formation, centrifuge the tube for 10 minutes at 1200 times G at room temperature with the brake on. Ensure that the centrifuge is adequately balanced. Following centrifugation, carefully and slowly remove the tube from the centrifuge to avoid disrupting the pellet. The next step is to collect the separated serum. If available, a pipette controller with 5 ml pipette should be used. Otherwise, a disposable 5 ml transfer pipette can be used. Aspirate the yellow serum layer while leaving a small residual serum volume above the clot in the tube to avoid contamination. Then dispense the serum volume into a 15 ml conical tube. Following capping, invert the conical tube at least 5 times to ensure mixing. Following mixing, use a pipette controller with a 5 ml pipette or a disposable 5 ml transfer pipette to dispense equal volumes of the aspirated serum into each of the 3 previously labeled cryo vials. Assuming full volume of blood collection, the aliquot should be 0.5 to 0.7 milliliters per cryo vial.
For research sample 3, following blood collection, the first step in processing is to invert the tube 10 times to ensure mixing, which I've already done for this tube. Then centrifuge the tube at 1600 G at room temperature for 20 minutes with the brake on. Ensure that the centrifuge is adequately balanced. Once the cells for research sample 3 are spinning in the centrifuge, place PBS and CryoStore on ice in preparation for later processing steps. Following centrifugation, remove the tube carefully to avoid disrupting the cells. PBMCs will be within a milky white layer just below the plasma layer. There may also be some minor blood contamination in this layer, which is not a problem. Underneath these cells is a polyester gel plug that traps denser blood components below it. In the biosafety hood, remove the rubber stopper on top of the CPT tube and carefully pour out the accessible fluid above the polyester gel plug into a 15 ml conical tube. Following this step, the CPT tube can be discarded in a biohazard bin. Next, take cold PBS from the ice. Using a pipette controller with a 5 ml serological pipette or the 5 ml disposable transfer pipette, transfer cold PBS to the conical tube to bring the total volume to 13 mL. Then mix by inverting the tube 5 times. After diluting the sample with PBS, place the 15 ml conical in the centrifuge at 300 G at 4 degrees Celsius for 15 minutes with the brake on. Ensure that the centrifuge is adequately balanced. Following centrifugation, remove the tube carefully to avoid disrupting the cell pellet. Using a pipette controller with a 5 ml pipette or a 5 ml disposable transfer pipette, aspirate and discard the clear supernatant fluid without disturbing the cell pellet. This fluid can be dispensed into another 15 ml conical waste tube. Be sure to leave a small residual volume at the bottom to avoid aspirating the cell pellet itself. Following the removal of the supernatant, flick the side of the tube several times to resuspend the cell pellet. Obtain the cryostore solution from the ice. Using a pipette controller with 5 ml pipette or a disposable 5 ml transfer pipette, draw up 3 milliliters of the cryostore solution. Then dispense it into the conical containing the cells. Some sites might have cryostore in a vial that requires the use of a 5 ml syringe and an 18 gauge needle to draw up the solution. Then, using repeated aspiration and dispensing, mix the solution and the cells. Make efforts to avoid introducing bubbles. After adequately mixing the cells in the cryostore solution, draw up the full volume using a pipette controller or a disposable transfer pipette. Then dispense equal volumes into each of the 3 previously labeled cryovials. There should be approximately 1 milliliter in each cryovial. After you have filled the labeled cryovials, they must be stored appropriately.
For research samples 1, 2, and 4, they can be placed directly into the -80 freezer in a freezer box. For research sample 3, which is peripheral blood mononuclear cells, the cryovials must first be placed into the supplied cell freezing container, which ensures a controlled decline in temperature to protect the cells. The cell freezing container is then placed in the -80 freezer for at least 24 hours. After 24 hours, the cryovials can then be transferred from the cell freezing container to the freezer box with the other samples. All samples must remain in the -80 freezer until time of shipping to the Atrium biorepository.